Okay, on Friday we covered parallelograms in our quadrilaterals book. I think I accidentally called this page 42. I transposed the numbers. It's definitely 24 in your notebook. And we learned about parallelograms, and then we practiced on delta math. The concept of a parallelogram, so all the properties of a parallelogram, carries over into today because rectangles are a type of parallelogram. Okay, I'm going to say it again. A rectangle is a parallelogram. It just has extra properties to make it look different than a parallelogram. Everybody knows what a rectangle looks like, but I doubt you knew all of the secret properties of a rectangle. So if you would open your flap carefully, you can see where we worked on Friday with parallelogram. Open the next flap to properties of rectangles. What do you notice at the top? What looks familiar? Yeah. Do you notice if you read through these blanks, do they look familiar? Look at the parallelogram flap at your desk. Go back to the parallelogram flap, and then look up at my screen. What do you notice? They're the same. That's because a rectangle is a parallelogram with extra stuff at the end. So take a second and copy the properties of parallelograms to the properties of rectangles. They are. We just have extra stuff to add to it. Now the only ones I want you to copy are the ones where you're filling in the blank. That extra property that we wrote on parallelogram by itself, don't copy that. Which it is true, but just there's no room to copy it. So opposite sides are what? Congruent? Opposite sides are also parallel. Opposite angles are congruent. Consecutive angles, we said we are going to call same side interior. Same side interior angles starts with an S, which means they are supplementary. And an S can be made into an 8 to help you remember supplementary means they add up to 180. If you have any AirPods in, go take them out. And then diagonals do what? They bisect each other. Remember that means that they cut in half. There's two aspects to all of these shapes. There's either angles or sides, diagonals. Okay? Angles, sides, and diagonals. The only one that involves adding up to equal 180 is angles. So please don't confuse edges and diagonals as adding up to 180 because that's not the case, okay? You can't throw 180 into an equation if you're talking about the edges of the shape. You can only use 180 if you're talking about angles. So make sure to keep that in mind. We have two new properties of a rectangle to keep track of for rectangles. you should know this next property. It says all blank angles. What do you know about the corners? They're what? They're right angles, not wrong angles or left. They're all right angles, which means every corner measures what? 90 degrees. You already know that. So please don't let that be something you have to memorize. Everybody knows what a rectangle looks like. If you look at your flip book closed, it's the shape of a rectangle. All of the corners are perfect L's. That's 90 degrees. Another new aspect, diagonals are blank. So remember I said a parallelogram is a rectangle that's been pushed, right? And because of that, now you have a short diagonal and you have a long diagonal. Well, if we're back to a rectangle, then the diagonals need to be what? To each other. Imagine if I take my arms and fold them to show the diagonals of a rectangle. They would measure what in terms of length? The same. Y'all with me? If you look at that picture, the diagonals are the lines in the middle. Come on, y'all. The lines in the middle. What does it look like they measure? Don't throw 180 in there. 180s with angles. Well, I mean, like, what do they look like? There's a short diagonal, a long diagonal. Do they look equal? Do they look?
They're the same.
Yeah, they're the same. Look at the rectangle. They're the same length. There's no short and long diagonal. Now, if you go back to a parallelogram, which there's a lot of work covering this up, but there's a short diagonal, and then there's a long diagonal. See the difference? It's rare that you're going to hear me say, just look at the picture. But with these shapes, you can just look at the picture. In a parallelogram, I clearly see a short diagonal, a long diagonal. In a rectangle, I clearly see two diagonals that when I trace them have the same length. So that would imply that they are congruent. Thank you. They're congruent. Now, there's a lot to put on this picture. I don't want to put too much because it starts to get overwhelming and then you kind of lose track of what was trying to help you. Let's only make marks on the new stuff, okay? All of the stuff from parallelograms still exists, but if I try to mark that on there, it's going to be a hot mess. So let's just mark the new things. The corner angles measuring 90 has already been marked, but I'm going to emphasize them. All the corner angles are 90. Now the diagonals are congruent. They also, what do they also do? They also bisect. So we have something really interesting here. First of all, they're congruent. Second of all, they've been cut in half. So how many equal parts do I actually have now, since they're congruent and cut in half? How many equal parts of the diagonals do I have? 4. I have 4 equal parts. Who answered me? Yes, very good. So I have this diagonal here cut in half, correct? Then I have this diagonal here cut in half. But because the diagonals in total are equal, then the halves are also equal. So I'm going to make marks that that's equal to that, to that, to that. Remember, don't throw 90 or 180 in here when we're talking about the length of something. 90 and 180 only comes up in angle measures. There's a big difference, okay? Something else happens, and it's not a property because it's just something that falls into place because of what you have in front of you. It also happened over here with parallelograms. We just didn't have any examples come up with it. But I wanted to show you this is coming down the pipes eventually. If I have 2 straight lines crossing, what type of angles exist? You should know this. This is from like 2-3 weeks ago. Keep going. Yes. Yes. That's actually more than I was looking for. What? Yeah. I was wanting that first and then I was going there. So that's awesome. So if you look at the picture, look at the two diagonals. You see how they cross? It looks like an X. When they cross, vertical angles are formed, okay? So like this angle here would be congruent to this angle over here. And then this angle here would be equal to this one down here. It kind of gets crowded. You don't have to draw all of them if you don't want to. But I need you to kind of just look at that and be like, okay, so that's possibly going to come up one day. And then, as Leah just said, not only do you have, well, Mia said triangles, and then Leah classified it as isosceles. Just focus your attention on one of these triangles, just one of them. We'll do the bottom one since it's already upright like a rooftop. Do you see the isosceles triangle now? Which means now you can start to see where geometry is layered. We're a staircase, and like if you miss one day, the next day is possibly harder because it gets pulled and reappears. That property does. If you have an isosceles triangle, turn it like a rooftop and find the base angles because they would be congruent to each other, right? Now don't mark this because then it would get really, really crowded. But basically, there's an isosceles triangle. There's my two congruent sides. So then whatever this angle is here would be congruent to this angle over there. That same concept would be true here, 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 here. Now you can see why this is a hot mess if I mark everything. I'm about to take those off. But do you see it though? Do you see there's 4 isosceles triangles in every rectangle? The ones that are opposite of each other, think of an hourglass. Like, if you want, there's one, there's the other. The hourglass ones opposite of each other, they're copies of each other. Okay? Let me take these books off. It's getting crowded. Okay. And then, do you remember the Pythagorean theorem? The Pythagorean theorem was taught to y'all in previous math classes, and it is back. Yay! It is back once again. It's going to come up maybe once or twice, not a lot. So if you have any room, kind of like we did over here where we added a property, if you have any room either right here or up here, it's up to you. I want you to add the property. Look for Pythagorean theorem and that's just to remind you that sometimes the Pythagorean theorem is going to come into play. And that's only because we have right angles now. If you recall, the Pythagorean theorem is when you're looking for a missing side of a right triangle. So you do have to have right triangles. Well, we're talking about a rectangle. There's right angles in a rectangle, so we have right triangles in here. If you're wondering where the right triangles are, look at this. Here's the L to show the right angle, right? And then if I trace the diagonal, then now I can see the right triangle. So the Pythagorean theorem may come up to show you to get the length of one of the edges or to get the length of the diagonal in total. Okay, so keep that in mind. That's enough talking. Let's dive into examples and then we'll go to our practice assignment. All right, I said it last Friday and we'll say it again. The first example is probably the toughest because they're putting so many questions on one picture. And then the next example is just one topic. So, well, let's work through this together. What is the difference between this and this? One's angle measures, one's length measures, okay? Remember we talked about that. So the only one that could involve 180 or 90 is the one with angles. So that's your indication. When I get over here to find these, I'm definitely not going to use 180 or 90 anywhere, because these are not angles. So keep this in mind. All right, we have a rectangle. Might help to come in here and say there's a 90, there's a 90, 90, so you don't forget. You are dealing with a rectangle. It might even help to mark your congruent sides. You've got left is congruent to right, top is congruent to bottom. And then your diagonal is 4 equal parts, right? So I'm going to come in here and make a note. This is equal to this, to this, to this. See how I did that? So now I've kind of made marks to remind me of what's equal. Okay, it says find KL. KL. What would it be? 35. As you find it, label it. Now it says find NL. It would be 20 because it's congruent to the other part of the diagonal that we know. So 20. Now KM. What? Who's saying that? And how'd you get it? If this is 20, remember we said it's 4 equal parts, so this is 20 and this is 20. Yes, it would be 40. So these were length. This is angles. All right, we've got angle KLM. So remember, you got to trace it with 3 letters. KLM. Did I just trace 2 edges? I traced 2 edges. That means I need the corner angle. It's a rectangle, so it's 90. LMK. So LMK. Now we're getting into the stuff we have to actually do a little work. Remember we said that this is a parallelogram, so it's exactly like on Friday. You do have alternate interior angles when the diagonals are drawn. We just didn't want to write it because it would make it even more crowded, but there are alternate interior angles here. If you notice, I'm looking for LMK. That means I'm looking for this angle right here. Well, I know the corner's 90, but I don't know this piece here, so I can't do 90 minus it. But if I, watch how I do this. If I come to the other side of the diagonal, so I'm here, and now I'm going to come down here and see, do I know that one? And I do, it's 61. So then this would have to be 61 because they're alternate interior angles. So this is 61 degrees. So I'll make a note. That was right here, 61. Now it says LJM. LJM. Which would be this corner here. Or not corner, but this part here. Well, what do I know the corner measures, y'all? The corner's 90. Go back to that isosceles. There's a lot of ways to get this. My mind sees it the following way. Go back to that isosceles triangle. Here's an isosceles triangle right here. Do you see it? This is equal to this. So this would measure what right here? 61, and the corner is 90. So I have enough to get this angle here. Bam. So I'm gonna walk through that again because once I start to like lead you there, it kind of falls into place fast. You may be like, what the heck did she just do? I focused on this I focused on this isosceles triangle right here. I know this is equal to this. So then I tilted my head to find my base angles that are equal. This would be congruent to this, which means this is 61. The goal was here. Well, the corner is 90, so 90 minus 61 gives me my answer. That's not the only way to get it, but that's the way my mind saw it. All right. Y'all stay with me. Kayla, wake up. Skylar, wake up. All right, let's look at the next one. It says if you have a rectangle, it says find the measure of angle QPT. So QPT. So this is what I'm looking for. Then I'm going to look at the picture and ask myself, what did they give me? They gave me some angle measures. You have to ask yourself, what's the relationship between the angle measures that they gave you? Well, remember, there's only three choices. They're either equal, they add to 90, or they add to 180. Those are your three multiple choices anytime you're dealing with angles. Look at the location of the angles to figure out what they do. It is pointing with an arrow. It's saying that 16x minus 6 is right here. And then it's saying that 10x minus 1 is here in this corner. What do I know about those angles? What? Why? Do you remember the vocab word to describe them? Yes. This would be congruent over here. They are alternate interior angles, which are congruent. They're equal. So you're going to set those up to solve for 180. I said them what? Do they add to 180? I said set them up to solve for 180. Set them up to solve for x. So how do I set it up? Yep. Skylar, wake up. Do you have your yellow flip book out? Can you get it out and fill in the notes for me, please? Michaela, wake up, sweetie. What'd y'all get for X? Now, what do I do now? Because the question didn't say find X, it said find the measure of an angle. Plug 3 in. All right, what am I going to plug it into? Okay, so you're going to plug it in here, so that's 16 times 3 minus 17. Now that's going to give me that little angle. What do I do with that? Is that my answer? Yes. Remember the goal. This is why it's helpful to put a question mark on your goal. This was the goal, this corner. Well, right now I don't have enough to get that corner, or that angle. But I know that the corner measures 90 because it's a rectangle, right? So this whole corner is 90. And I've got X, so I can figure out this little chunk and then take that off 90, and I'm left with the answer. We are definitely in the stuff that involves multiple steps, which is grade level content, okay? You're a sophomore in high school. You really shouldn't be doing stuff that involves one step. Like there should be layers of thinking in here. And that is exactly what we're doing right now. So So plug 3 into the angle that we talked about, and then take that and subtract it off 90 and get your answer. What'd you get? 59?
I have 31.
So 31 means you're close, you're not quite done. 31 would be this angle right here, like this angle here.
So you have to add them together?
Well, no, what's the corner going to measure? Because it's a rectangle. Don't forget.
I thought that was the outside.
31? What, you thought
No.
31 was the outside?
No, I thought the outside.
So this is a angle measure, and the arrow's saying that they want you to call that little purple angle 16x minus 17. So we plugged x in and we got 31. Right? Did you get 31? Okay. All right, so this is 31. But we want green.
This the outside, right?
Yeah, it's right here. Yeah. And it's a rectangle, right? So what's the
Never mind. Never
You
mind.
see it now?
Never mind.
You're fine. Do you see it now though? The corner is
Never mind.
90. You're fine. So 90 minus 31, and the answer would be, what did we say? 59 degrees. You're going to keep your yellow flip book out to help you here. This is page 25. Properties of rectangles. There's no delta math on rectangles. We're going to do this worksheet instead. Kind of mix it up a little bit. The front of the worksheet is all numbers. The back of the worksheet has algebra. Okay? So that's how it's organized. The front's just numbers, the back is algebra. So when you get to the back is when you're going to have to set up equations. Either two things equal. If we're talking about angles, they can be equal, they can add to 180, or they can add to 90. If we're talking about lengths, they could be equal, or something could be cut in half, right? Okay, so you do have some multiple choice options here. Looking at the front, they have copied the properties of parallelograms right here. That's what these are, properties of parallelograms. And then they put 2 blank boxes for you to remind yourself that all, let's don't write all right angles. We'll say all corner angles equal 90 degrees, right? The corners are all 90. And then the other property was the diagonals are congruent. There's 2 things you need to remember that will also come up. You've got the Pythagorean theorem, and then you've also got isosceles triangles in here, okay? Look for your isosceles triangles, because the base angles of an isosceles triangle are equal. All right, so look at number 1. We've got, this is 10, this is 24. It says find the missing measures. QR. What would QR measure? Yep, 10. It helps to label as you go. What would SR measure? 24. Now it wants SQ. So I'm going to draw a line on SQ. We're going to look at the diagonals. Do we know a single diagonal or part of a diagonal in the picture? We don't know anything about the diagonals, right? This is blank, 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 blank. So that's your indication that you're going to have to use the Pythagorean theorem here. Take your pencil. I want you to darken SQ. And then there's actually multiple right triangles here. I'm going to go with this one. And I'm going to darken these edges as well. So now I can actually visualize the right triangle. What is the corner measure? 90. So if you need to, you can come over here and copy it. We're looking for this. We know this is 24. We know this is 10. We're going to do the Pythagorean theorem. Quick refresher on the Pythagorean theorem. First of all, it's a squared plus b squared equals, do you remember? C squared. You got a squared plus b squared equals c squared. Do you remember which letter has a restriction on it? Like it has to be a certain side. Do you remember? By chance? Huh? C. C has to be the hypotenuse. If you don't put the hypotenuse in place of C, you're going to get it wrong. What is the hypotenuse? The hypotenuse is the, do you remember? Try me, y'all. The hypotenuse of the triangle is always the short side, long side, opposite of the, what? The longest side. Hypotenuse is the longest side of a right triangle. What side would always be the longest? The one opposite of what? In a right triangle. Yes. The one opposite of the right angle. I want you to draw an arrow from the right angle to the side opposite. That one's always your hypotenuse, every time. The longest side of a right triangle is opposite of the hypotenuse. So what letter can I call this that would help me with my formula? C. I could call this C. Now, does it matter how I use these two? It does not matter at all because they're just going to get squared and then added together, which means the order doesn't matter there. So it doesn't matter how you plug 24 and 10 in, as long as it goes in place of A and B. You with me? So we got 24 squared plus 10 squared equals C squared. I really hope you're trying this and I'm not just like guiding you through, dragging you across the finish line. We need to figure out what these are. So you go to your calculator and you would type, this is a standard equation. Type that in. See what you get. What do you get? 676. Now we need C squared to be just what? C squared needs to be what before I'm done here? I need it to just be C. The squared's got to go, right? How do you undo squared? Square root. So we're going to square root both sides. That'll bring that to just C. You got to go to your calculator and square root 676. To push the square root button, you're going to punch second, and then it's actually the square button, the one that says x squared. If you look above that, you'll notice that there's the square root symbol, and that's because they're inverses. But you do have to hit the second button first. So you're going to type second. Wait a minute, clear that. Clear that. That's going to be a hot mess. There you go. Type second. There you go. and then type 676. Second square root 676. What do you get? 26. Now let's put it all together. 26, that would be the length of this, and that was me copying from here, so this whole thing from here to here is what? 26. Well, then what would PR measure? Yeah, diagonals are congruent. PR is the other diagonal, so it's 26. So what's QT measure? What? 13. Why? Yeah, the whole, remember we said you've got 4 equal parts in here. Well, if the whole thing's 26, then each part is 13. Y'all, that's as ugly as it gets with that Pythagorean theorem. Okay? Let's go to number 2. Find AC. A to C would be what? 30. Because I know part of it's 15, right? Alright, what about B to D? That's the other diagonal in whole, so it's 30. What about BE? 15. What about AB? That took less than 1 minute to answer those questions all together. Now, BC. BC is, hold on. Alright, BC is here. This is what I don't know. I just labeled AC to be 30. We said BD is 30. We said BE is 15. We said AB is 27. We know this is 15. And now I'm looking for this over here. How am I going to get it? It's going to be another, what? Yeah. We've got this side here I'm looking for. I don't know it. I do know this is 27. I do know this is what? Total. 30. And this is a corner, which measures 90. So I have what shape here? I have a right triangle. So I'm going to come over here and redraw it so you can see my numbers. This was 30, this is 27, and this we don't know. So I can call it what letter? 2 answers here. I can call it A or B. Does not matter. We'll call it A. Can't be C though. C is the hypotenuse, right? C is the one opposite of the right angle. This has to be C. So we're going to plug it in. We got A squared plus B squared equals C squared. Don't know A. B is 27. C is 30. Before I can get A squared by itself, I need to shift some stuff. I also need to square these numbers, right? So, someone tell me what 27 squared is. 721? 29? Is that right? And 30 squared is 900? What do I need to do? Subtract 729. What do you get? 171. Now what do I do? Square root both sides. Well, we'll go to the nearest 10. What do you get? Okay, so we'll do 13.1. Like I said, that's the toughest it gets. It's the same thing every time. It just, what might change is where your variable is. Okay, so 1 and 2 practiced with the length of the diagonals and the sides. Let's practice now with the angles. 3 and 4 have to do with just angles. You're going to notice, look at this picture in number 3. This is crazy. I have a rectangle in front of me. They're only showing me one angle measures 27. Somehow I'm about to be able to figure out all of the other angles because of that one piece of information. What do we know about the corners again? They equal 90, so it might help to draw that so you don't forget. They do add to 90. What do we also know about the diagonals? The diagonals in a rectangle they're all equal, right? All 4 parts. So to help you see those isosceles triangles, you might want to draw the diagonal congruent marks, and then that way now you remember there's isosceles triangles here. And here's why you need that. That 27, by the way, is referring to this corner here. It's talking about this one. I'm not even going to look over here at these angles because it's going to drive me nuts. I'm just going to start figuring out these angles in the picture. I have an isosceles triangle up here in the top, right? It's completely upside down. If this is 27 here, then what's this? This is also 27, right? What do I know down here in the bottom? They're exact copies of each other. We talked about that. We said it's like an hourglass shape, like the triangles that make it the hourglass. They're exact copies of each other. So every single one of those congruent marks that I just drew would measure 27. Now, if this is 27 and the corner's 90, do I have enough for here? Yeah, 90 minus 27, right? What do you get? 63. So this is 63 here, which means this is what? 63. So what's this over here? See how this just falls together? Now there's one pair of angles we've not talked about yet, and the way you would get there is using the shape of a triangle. I'm going to change colors because it's already getting crowded. Do I have enough info for this angle here? From here to here. Do I have enough info? What about now? I know this is 27, I know this is 27, I know they add to 180 because it's a triangle, right? So 180 minus 27 minus 27 is what? 126. You see how we got that? It's a puzzle, y'all. And it has a domino effect. Like once you find one little piece of it, they all start falling into place. And there's symmetry. Symmetry means like if you find the top, you found the bottom. If you find the left, you found the right in a rectangle. So what would this down here be? 126, but now I'm covering the pen, so I'm going to take that off. Do I have enough for this angle? 2 ways to get there. You can focus on this triangle, take off 63 and 63, or I see a faster way. What's this measuring? What? 180 because it's a linear pair. See how all this comes together? So this is a linear pair. So 180 minus 126 would be 74. Not 74. 54. So that little corner in there is 54. I've not looked at a single question yet. All I did was sit there and start filling in the angles based on the one they gave me. Now I shouldn't have any work to do besides reading the angle. All right, we've got MJK. MJK. Makes a perfect L. It's a corner, so what's it measure? 90. Now we have MJL. MJL. We already found it. It's what? 63. Now we have JLK. JLK. We already found it. It's 63. KML. KML. 27. I have that marked there to remind me it's 27. MNL. MNL would be vertical to the 126, right? This angle here would be vertical to 126. Number 4 is the exact same type of problem. The angle they give you is not one of the isosceles, it's one of the vertex angles. If this is 64 here, then what's this? 64. This would make a linear pair, right? So what would it measure? 180 minus 64, what do you get? 116. So what's this? What are the corners? 90, 90. Now I want you to write your isosceles angles and find the angles in the corner. Oh, happy day, right? Now you're going to use the isosceles triangles to help you get these angles down here in the bottom. Focus on one at a time, okay? Just focus on one triangle at a time. It's the same logic every time. Y'all want to focus on this one since it's not as crowded, this one up here. Remember, these diagonals are all equal. So focus your attention on this triangle. It's isosceles. The top is 64. So if, I'm going to draw it down here. If the top is 64, the base angles would have to be equal. Do I have enough to find them? Please say yes. What is the sum of the angles? 180. How much has already been used? 64. So how much are we working with? 114. 116. So if we have 116 total and we know the two angles left have to be equal, what do I do with 116? Divided by 2, and what do you get? 58. So this is 58, and this is 58. Now you've got enough to figure out that other little angle, and then they all fall into place. Okay? Your practice assignment is to finish this sheet. I would like to go to the back and give you the final answers on the back so you know if you did them right. The front, I can't give you the answers because you saw that a lot of them are just looking at the picture and writing it. So I'm not going to give you the answers on the front. I helped you with 4 of them. That was quite a bit. But I am going to give you the answers on the back. If you want to just write them really. So now these are the final answers, okay? So be careful. A lot of them you have to find X, then you have to do something with it. I'm not going to tell you what X is because then it would be easier to do the, you know what I mean? So the final answer here is 38. 13, 54, 34, 71, 23, 57, and 12. Those are the final answer after you find X and plug it into something. If you want to jot those down.